In this chapter we will look at cluster scaling. To increase the performance of your cluster to cope with an increasing load, you can expand the agent pool size. Decreasing the pool size is also supported, allowing you to save on Azure consumption costs. Note that automatic scaling is not supported at this time. When using Docker Swarm, the scale operation is applied to the agent scale set. If you are using DCOS, the scale operation is applied to the private agent scale set. And finally, for Kubernetes, the scale operation is applied by adding or removing separate virtual machines in the availability set. There are three ways to increase the ACS agent pool size. One is by using the Azure portal, two is by using ARM templates, and three is using the Azure CLI. In Module 1 we learned that, due to the stateless nature of containers, it makes sense to store data produced by a container outside of the container. This way a container can move from node to node without the chance of data being lost. Because of scaling, agent nodes may come and go. Removing a node should not result in data loss, so it makes sense to store data not only outside the container, but preferably outside the cluster. You can do this by attaching separate data disks to the cluster nodes or by using file shares. Each of the cluster orchestration tools we discuss in this course supports attached storage for their containerized workloads. Before a node can be removed from the cluster, it needs to be drained of services and state. This means that other nodes in the cluster take over the work of the node that will be removed. All the orchestration products we are discussing in this course support this feature.